Now that we have a firm idea of the economic resources and the income associated with the economic resources, let's get back to the idea I mentioned earlier about economic efficiencies. Broadly defined, there are three types of economic efficiency. The first one, straightforward and simple to explain. The production possibilities model is going to quantify numerically and graphically the absolute limitations of production in a given time period. In order for an economy to achieve somewhere along that possibility, that country needs to employ all of their available economic resources. So that's what the concept or the idea or the principle of full employment means. Full employment, as it refers to efficiency, is simply putting to use all of your available resources. All land, capital, labor, and entrepreneurial ability. Now, of course, not all resources are available in a given time period. So, for instance, we don't timber every tree, and we don't fish a limitless amount because we want to replenish the oceans for future generations or future years of fishing, but putting to use all of your available resources. Productive efficiency is likewise a pretty straightforward concept. If you take a simple product, something like a pencil, good old number 2 pencils that we all had to use for our SATs, those were fun, right? You think, okay, how much does it cost the manufacturers of pencils to make a pencil, right? So there's some land resources in there. There's some capital resources, the machine that cranks out the pencils. There's definitely some entrepreneur who came up with the idea of how to get the eraser to get on there perfectly, and the thing would sharpen perfectly. All right, so we got land, we got capital, we got labor, we got entrepreneur ability. All those economic resources are necessary to make the pencil properly. Productive efficiency is a simple idea. Produce in the most cost-effective method. So if it takes 30 cents worth of economic resources to produce one single pencil, don't use 33 cents. Use 30 cents. All right, if you think about a product or a service that's a little more sophisticated, something like a new 70-inch LED television, it might take, let's guesstimate, $245 worth of economic resources to produce that product. So produce the most cost-effective method. Don't use $250 worth of economic resources if it can be done perfectly with $245 worth of economic resources. So productive efficiency, produce in the most cost-effective method. So number 1 and number 2 are straightforward. Number 3 is a bit more challenging, but it will come to light more clearly as we get into the heart and soul of the production possibilities frontier. For now, let me do my best to explain it to you students. Allocative efficiency refers to the proper combination of output most desired by society. So, productive efficiency and full employment, those are positive economic ideas. There's an absolute number associated with the most cost-effective method of producing an iPhone. There's an absolute number associated with the land, capital, labor, and entrepreneurial ability available to produce products and services in a given time period. So productive efficiency and productive efficiency and full employment are positive economic concepts. Allocative efficiency is more of a normative economic concept. There's some bias, there's some judgment involved there. For instance, two societies with similar types of government, similar availability to resources, and similar populations might choose differently when it comes to the combination of consumer goods versus capital goods. So, how does the society decide which combination of goods and services maximizes the utility of the citizens within that country? That's a good question, and we will tackle that at a later date further on in our study of the production possibilities model. We're just about to construct our production possibilities model. Every production possibilities model or production possibilities frontier is built on 4 important assumptions. Remember, the production possibilities curve, or the frontier, represents the absolute maximum level of production that can take place given society's limitations. So, if a nation is going to produce anywhere along the curve, anywhere on the production possibilities frontier, the first assumption is full employment and productive efficiency. If we are to achieve maximum level of potential production for the time being, the nation will be putting to use all of its available resources, full employment, and producing goods and services in the most cost-effective method, productive efficiency. The second and third assumptions go hand in hand. The second assumption is that for the time being, we're dealing with fixed resources, both in quantity and quality. We only have so much natural gas, so much oil, so much copper, so many minerals, so much wind and solar power available, so many labor resources. We know in the future there may be more resources available, or even improvement in the quality, so better resources available. But we're going to assume that the production possibility frontier represents, for the time being, fixed resources in quantity and quality. Likewise, we have fixed technology. That is to say, we're going to employ or use the best methodology, the most superior approach to producing goods and services. But those methodologies, for the time being, are fixed technology. In the future, there's going to be a more efficient, quicker way to produce automobiles because we'll have better machines that make fewer mistakes and get things done faster. We'll have more efficient solar panels that are able to capture more sunlight and also create more combustion energy from that sunlight. However, for the time being, we have to deal with the technology of today. The last resource is that the last assumption is that the production possibilities frontier is going to evaluate the trade-off between two products. One will be on the vertical or y-axis, one will be on the horizontal or x-axis. However, these products can be broadly defined. The McConnell textbook example, which we will cover in detail in class, shows the trade-off between pizzas and robots. However, pizzas in this example represent all consumer goods, and robots represent all capital goods. Therefore, the assumption of two products does not deter the importance of the model. Okay, we've been talking principally about macroeconomic examples of, or macroeconomic applications of, the production possibilities frontier. But we're actually going to start with a microeconomic example. Here we have the Sarah Study World Production Possibilities Frontier. Sarah is taking two classes this semester, an economics class and an accounting class. Notice her expected grade for economics can be found down bottom on the horizontal axis, and her expected grade for accounting can be found on the vertical axis. Now, Sarah has not been the most diligent student. As a matter of fact, Sarah has done nothing all semester for either one of these classes. For simplicity, we're going to assume that her entire grade for both of these courses is determined by her performance on the final exam. So, she has exactly 10 hours left to study. It's midnight before the final exams take place. One exam starts at 10, the other exam starts immediately after the first exam. Therefore, she has exactly 10 hours of study time. So let's talk about her choices, her costs, her limitations. One possibility is Sarah spends all 10 hours studying accounting. That's definitely an outcome that is possible. Notice what happens. If she dedicates all of her potential study hours to studying accounting, she does rather well in accounting. She achieves an A. But the trade-off is her grade for economics is F. So A in accounting, but F in economics. Probably not a desirable outcome. So Sarah decides to shift some of her time away from studying accounting and towards studying economics. Now notice, she cannot have more of both. Remember our first important economic idea associated with the model, absolute limitations. So if 2.5 hours are shifted away from studying accounting and into economics, notice that the cost is a drop in accounting grade from A to B, but the gain or the trade-off is an increase in the economics grade from F to D. Sarah could also have an even distribution of hours studied, 5 hours for each accounting and economics. This yields a C for accounting and a C for economics. But notice, as she dedicated more hours away from accounting, her accounting grade dropped from B to C, and her econ grade increased from D to C. Now we could play this game all day, but here's the most important idea. We can draw the production possibilities frontier representing all potential outcomes for Sarah's grade. Two things are extremely important about this particular production possibilities model, or this particular production possibilities frontier. The first, it's a straight line. In other words, it's linear. Whenever students come across a linear production possibility frontier, a linear production possibilities model, it's driving home an important economic idea. And here is the principle associated with a linear production possibilities model. If the frontier is straight, it means that there's constant costs along the curve. In other words, every time Sarah gives up 1 grade in accounting, she gains exactly 1 grade in economics. And that's true along the entire frontier, a 1-to-1 ratio. Now, the ratio does not have to be 1-to-1, but it's constant. In other words, it could be, in future examples, 1 down, gain 2, 1 down, gain 2. But the point is, constant cost along the curve. The trade-off is the same. Every time she wants more of one, she gives up the exact amount of the other. So the opportunity cost stays or remains the same along the entire production possibilities frontier. Now, in reality, we don't really know much about Sarah's life. Is she an accounting major and she needs the A, and the economics class is just an elective? Okay, maybe this is the best outcome. Or vice versa, she's an econ major and she doesn't need the accounting grade. This is the best outcome. But without any further information, we would assume that the 1 point along the curve that is the proper distribution of, or the proper combination of, both of these products is right here. C for accounting, C for economics. This particular point would therefore be allocatively efficient. Remember, allocatively efficient? The proper combination of goods and services most desired by society, or in this case by the individual.